The 5Watter kit doesn't come with a case, and having a 3D printer, I figured, okay, well, I'll just figure out how to 3D print one. And I was originally going to design my own from scratch, but I came across this absolutely fantastic OpenSCAD project on Thingiverse called the Parametric Ultimate Box Maker. And there's some examples here of different shapes it can do. It has this really nice panel designer that can do front and rear panels and vent holes and pretty much everything you need. Now I customized it a little for my application, so I'll take you over to OpenSCAD and we'll see what modifications I've made. Okay, so here we are in OpenSCAD, and you can see that the box maker gives you some point and click out options here for setting different variables. One of the things that's really nice and helpful as you're designing the panels is you can actually turn off the generation of the box parts and just do the panels, which print pretty quickly. They're not very big. But well, let me turn the top shell off here and kind of rotate this around. One really cool thing is it has a generator for PCB feet. So it's really easy to generate little standoffs with 3mm holes in there for 3mm screws. Now the panels themselves are not point and click. You have to actually edit the code to do that. And so if I go over here, there's a front panel, and there's some example code here that they provide, and then this is the code that I provided. And I plan on using a QRP guy's frequency counter in this radio, so that's what these 4 holes and that cutout are for. And then I have the tune dial, potentiometer, the command button, headphone jack, and volume potentiometer all on the front. And then I additionally created a back panel module object here, and these square holes are actually for the D-shaped holes for the power adapter, the key jack, and the BNC connector. So here we are over on the workbench, and you can see I've got the radio cased up. I printed the case in green and black PETG with 0.35mm layers because I'm kind of impatient, and also, you know, for something like this, I don't think the big layer lines really matter. And you can see it has vent holes, which are convenient because our transistors there and those heat sinks will appreciate that. And then you can see how the cutouts came out, and I separately 3D printed a knob. And you can also see here, as I mentioned in the previous videos, I was going to use a 100K multi-term potentiometer. Now this is kind of a beast of a potentiometer, but there you go. And everything's wired up. I even, learning from my previous mistakes, went to the trouble of putting some heat shrink to act as stress relief on all of the connectors, also to prevent shorts while I'm poking around in there. And as you can see, the command button and the volume knob and the headphone jack are all on the front underneath the tuning pot. And then the power jack, and you can see the power jack is round with square holes. Well, it would have been challenging or taken more work or more expertise in OpenSCAD than I have in order to build that. So I just did a rectangular hole, which has enough to keep the connector from rotating, but on this one leaves little gaps. I suppose there's an option in there to chamfer them, and I thought maybe if I had chamfered them they'd look a little bit better, but it doesn't affect the functionality at all. And then the BNC connector is kind of the same story. you can just barely make out there where the square part of the hole is leaking through. It's a little bit more round than oval shaped, so it worked out better for the BNC connector. The next step here, I need to do the transmit frequency alignment, and then the VFO kit finally shipped on Friday, so I'll be assembling the VFO kit, and I think I'll do another video about how the VFO kit works. This radio actually has right there a header for sampling the frequency, and it even has over here under these wires an aux header for providing 5 or 12 volt power to a frequency counter. So it'll turn out pretty nice and actually be really easy to get the thing hooked up and have a frequency dial so that I'm not just tuning by ear. I realized I didn't show you what it looks like when it's put all together. So let me do that real quick. You can see it's actually pretty handsome. Cables kind of provide a little springiness there. And then if we compare it size-wise, this is a QCX Mini, so obviously bigger than a QCX Mini, but that's not really unexpected. Right now, without the VFO in it, it's a little bit lighter, maybe about the same weight as the QCX Mini. But there you go. Like I said, the next video I'll probably be putting the VFO together and installing that, and then we'll do the transmit frequency alignment, and this thing will be ready to get on the air.